For this first FRQ, we have a piecewise function as defined, and we want to first find the average rate of change of f on the interval from -3, on the closed interval from -3 to 4. So keep in mind, average rate of change is just slope. So we will look for change in y over change in x, which is just, help if I wasn't on the eraser, f of 4 minus f of -3 over 4 minus -3. So that is change in y over change in x. So f of 4, well, for 4, we'll use this function, some brackets. So f of 4 will be -4 plus 3 cosine 4 pi over 2 minus, for -3, we'll use this function. So this will be the square root of 9 minus -3 squared, all over 4 minus -3, which is 7. Now we'll just simplify. So we'll have -4 plus 3 times, well, this is cosine of 2 pi, which is just 1. 9 minus -3 squared is 0. Square root of 0 is 0. So minus 0 all over 7. So we end up with -4 plus 3, which is -1 over 7. So that's our average rate of change, or slope, from -3 to 4. For part B, we're finding the equation of the tangent line. So, first of all, for tangent line, we have to find the derivative, because the slope of the tangent line is just the derivative. At x equals 3, the function we will use is this one right here. So that falls in that interval from 0 to 4. So then f prime of x will be -1 plus 3 times derivative of cosine is negative sine of pi x over 2 times the derivative of our inside, which is just this. Derivative is pi over 2. Let's simplify a little bit before we evaluate at 3. F prime of x is -1 minus 3 pi over 2 sine of pi x over 2. Now let's find the slope at 3. F prime of 3 is -1 minus 3 pi over 2 sine of 3 pi over 2, which is -1 minus 3 pi over 2 times, well, sine of 3 pi over 2 is -1. So we end up with -1 plus 3 pi over 2. And that's the slope of our tangent line. In order to write the equation for a line, you need two things, a point and a slope. So we already know that our x value for our point is 3. We need to find our y value. So to do that, we'll plug into our original equation. And our original equation is this one for 3. So if we plug in there, f of 3 is -3 plus 3 cosine of 3 pi over 2. -3 plus 3 times the cosine of 3 pi over 2 is 0. So our y value is -3. So our point is then 3, -3. We have our point, we have our slope. So the equation of our tangent line, we'll use point slope, and we'll get y plus 3 equals -1 plus 3 pi over 2, kind of an ugly slope, but still works, times x minus 3. And that's the equation for our tangent line. For part C, we want to find the average value. And remember, the equation for the average value is 1 over b minus a times the integral from a to b of f of x dx, whatever it might be. So here we have 1 over 4 minus negative 3, because we're going from negative 3 to 4. And the integral from negative 3 to 4 will have to be split into 2 pieces. So from negative 3 to 0, we have this piece here. So it's the integral of the square root of 9 minus x squared dx, plus the integral from 0 to 4. That's this other piece of negative x plus 3 cosine of pi x over 2 dx. So we end up with 1/7, this is 1/7 times those integrals, and we get negative 0.133. Use your calculator on this. For the second integral, you could do that yourself. The first integral is a BC topic, so right now you can't. Okay, part C. We're looking at, must there be a value of x at which f of x obtains an absolute maximum on the closed interval? Justify your answer. Well, basically we need to know if the function's continuous from negative 3 to 4, and if it is, then there must be an absolute maximum and an absolute minimum. So, continuity test. And with a piecewise function, well, we know that this is continuous on that interval. This is continuous as well. We really just need to check at 0, at the connectors. So first step, the limit as x goes to 0 from the left of f of x equals, well, let's see, from the left, we'll use this function. From the left, we have the function square root of 9 minus x squared. So we end up with the square root of 9 minus 0 squared, which is the square root of 9, which is 3. The limit as x goes to 0 from the right, or from the positive side of f of x, is this other function. If we put in 0, we get 0 plus 3 times the cosine of 0, or 0 plus 3 times 1, which is 3. So because of that, since the limits from the left and right are both 3, the limit as x goes to 0 of f of x is also 3. So the limit exists. Good. Step 2, does f of 0 exist? Well, at 0, we actually end up using this function because it's included. Square root of 9 minus 0 squared is 3. Good. Function exists. And the limit as x goes to 0 of f of x is equal to f of 0, and it's 3. So it passes the continuity test. And since f is continuous on the interval, I almost said integral, from negative 3 to 4, it must have an absolute maximum. Looking back at our question, yep, we were looking for an absolute maximum. Technically, it has an absolute minimum as well, but that's not addressed in the question.